Now we are going to specifically see. See, so far we have seen the variation in general. For any variation collector current, I will be using thermistor sensor. Now it is specific to a particular parameter. If my VBE is going to change with temperature, how I am going to act on that? This is specific to variation in VBE. So compensation against variation in VBE. You know VBE is the base emitter forward bias voltage. And you know emitter based junction is forward bias, collector based junction is reverse bias, right? So we are going to see if this VBE is going to vary with temperature, how I am going to handle that. Okay, so directly I have drawn the Thevenin's equivalent circuit. You know RB here, and RB is R1 parallel to R2. In the emitter fixed voltage divider bias, you have R1, R2. When we apply Thevenin's theorem in the last class, we have seen the Thevenin resistance is RB given by R1 parallel to R2. So they have drawn the equivalent circuit directly. So this is the voltage divided bias with the equivalent Thevenin's equivalent circuit. And what additionally we have here, see, usually you have a emitter resistance followed by ground. But here in emitter, I'm going to have this diode. I'm going to have a diode resistance RD, and I'm going to have a VDD. Okay, diode, resistance, and VDD. So this is going to be the additional circuit, which is this is the additional circuit which is going to be connected in the emitter side. Okay, so VDD is separately used because I want to keep this diode always in forward bias condition. So see here, positive to positive, negative to negative. So it is a forward biasing, forward biasing power supply. I am giving it to my diode. So usually when you connect your diode to the same polarity of battery, it is called as forward bias, right? So here also I am connecting the positive of diode to positive of battery, negative of diode to negative of battery. So I am going to have this diode in forward bias always. In the emitter side, I am going to have a diode which is always forward biased. Okay, by this VDD. Okay, if the diode, assume that the diode is made of the same material as the transistor. Transistor and diode are made up of same material. If transistor is made up of silicon, diode is also made up of silicon. If transistor is made up of germanium, diode is also made up of germanium. Okay, so that I'm going to ensure that if the diode is the same material and the same type of the transistor, then the voltage across the VD will have the same temperature coefficient as the VBE. So whatever variation you are going to have in VBE, the same parameters will be applicable to VD, because I'm assuming the diode and the transistor are made up of the same material. So analysis is going to be very, very easy for me because they are made up of same material. So the characteristics will be same for both.